Definition of absolute value, the like technical definition of absolute value is distance from 0 on a number line. And now, if you're going right or left or up or down or forward or backwards, and you go 15 feet in any direction, is there any way for that distance to be negative?
No.
No, because you still walk 15 feet. It doesn't matter what direction you go, right? Like if you're driving on a map, if you're going north, it's not positive, and if you go south, it's negative distance. It's always just distance, right? So distance is always positive. And since distance is always positive and absolute value is distance, absolute value is always positive. It cannot be negative. So if I give you a 4 and I asked you the absolute value of 4, it's 4. If I ask you the absolute value of negative 4, 4. 328? Negative 423? 423. It's always positive. If you have what I like to call stalker negatives, where the negative's on the outside, the absolute value of negative 2 is 2, but you've got this like lurking stalker negative out here. So as soon as this 2 comes out from its lovely little absolute value apartment, the stalker's there. So it's like following the 2. Okay, and it's the same thing if there's a negative outside of a positive number. As soon as that positive number comes outside, the negative's like lurking, stalking, so it's right there. Step 1 is you're going to plug in the given values for the variables. So we're going to take this negative 7.5 and we're going to put it right there where the n is. So I get 8.4 minus the absolute value of 2 times negative 7.5 plus 5 absolute value. Okay, step 2 is we're going to perform any operations inside the absolute value. And that's, the addition, the subtraction, the multiplication, and the division. Okay, so 2 times negative 7.5 is negative 15 plus 5. So that gives me negative 10. And then we're going to take the absolute value. So I get 8.4 minus 10, and then the last step is to simplify. So 8.4 minus 10, that's negative 1.6. Now you'll notice not at any point, like if we had parentheses here, I'd have a negative and then a negative 10, and I would multiply the negative into the negative 10. Like, this is what I mean. Now, you see how parentheses is a curve, and so that negative can like slip in there and affect this 10 on the inside. So that would equal a positive 10. But what happens when you have an absolute value wall? I like to call them walls. The negative tries to go in, bashes into the wall, and falls down. And it just hangs out. They can't go in. Like the parentheses, they can like slide in, but with the absolute value, you cannot bring anything into the absolute value. It's a wall. So it just gets carried down. So like it slams into the wall, it falls down. If we have a fraction, same thing, we're going to plug this in. Oops, 2 times negative 2/3 plus 1. I'm going to convert this to an improper fraction. I don't like dealing with mixed numbers, personally. So to convert that to an improper fraction, I multiply here, and I add here. So 3 times 1 is 3, plus 1 is 4. So that becomes 4/3. 2 times negative 2/3 is negative 4/3. Plus 1. Well, I'm going to change that 1 actually also. Oops. That's not what I meant to do. A 1. If I want to turn a whole number into a fraction, I pick my denominator. Well, I'm going to pick thirds because we're in thirds, right? And I multiply that number times whatever denominator I picked. 1 times 3 is 3, so it's 3/3. Okay. Negative 4/3 plus 3/3 is negative 1/3. The absolute value of negative 1/3 is positive 1/3, but this negative is outside is just lurking, right? So it stays there. So I get 4/3 minus 1/3, so it equals 2/3. Because it's 0.5.
3.5.
Yeah. So I'm going to plug in the negative 2. Oops. Okay, we'll go ahead and convert that to a decimal. A half is easy because it's 0.5. So I get negative 8 plus 3 minus 3.5. So that gives me negative 5 minus 3.5. So that gives me 5 minus 3.5, which is 1.5. Okay, decimals that are easy, or sorry, fractions that are easy to convert to decimals that will stay accurate are your halves, fourths, usually eighths, fifths, tenths, and then multiples of these, like 20ths and things like that. These give you nice, even fractions. Anything that's a multiple of 3 as a denominator, so 3, 6, 9, 12, etc., give you bad decimals, repeating decimals. So multiples of 2 and 5 are nice. Multiples of 3s are bad, and then the other ones like 7s and things of that nature, it just sort of depends. That was a good catch. It's not 2/3. It's 4 minus 1 is not 2. It's 3/3. So it's 1.
So I was off by 0.1?
Yes.
So
okay.
Would you accept that on the test?
Yes.
Awesome.
Thank you, Letitia. Variable inside. Okay, if x is 2, what, or the absolute value of x is 2, what is x? Or negative 2, right? Because the absolute value of 2 is 2, and the absolute value of negative 2 is also 2. So if you have the absolute value of x is 2, you have 2 possibilities, and it's an or, because we don't know which one it is. So if the absolute value of x is 3, x equals 3 or negative 3. If the absolute value of x is 14, x equals 14 or negative 14. If the absolute value of some number equals a negative number, can absolute value be negative? No. So if you get a situation like this, you have no solution.
Could have just told me that.
Because it doesn't have the creeper.
Yeah, if there was a negative outside here, then you divide both sides by the negative. But because it's just absolute value equals a negative, that's not possible. So there's no solution. Because absolute value is always positive. Well, if x was alone, x could equal 9 or negative 9, right? Well, x is not alone, so that means x plus 12 equals 9 or negative 9. So the first thing we have to do is we have to split it into 2 equations. So I have x plus 12 equals 9, or x plus 12 equals negative 9. So one equal to a positive and one equal to a negative. I guess there's not really 3 steps. Okay, step 2 is to solve each equation. So we're going to subtract 12 from both sides. On both equations. So x equals -3 or -21. Now, if you don't want to split it into 2 equations, there's another way you can do this. You can say x plus 12 equals 9 or -9 and do it as one equation with an or already in it. And then when you subtract 12 here, you have to also subtract 12 here and here. So you get x equals -3 or -21. So you can do it all in one if you'd like to. You just have to remember to keep that or in there, and whatever you do to this side, you also do to 2 places over here. Same. So we're going to split it into 2 equations. Okay. Subtract 5 from both sides. So y equals 3 or -13. Okay. If you have something going on here where we have some stuff inside the absolute value and some things outside the absolute value, we're going to get the absolute value completely alone first. So we're going to subtract 8 from both sides. And so I get the absolute value of 3x minus 2 equals -7. Oh, wait a minute. Can the absolute value equal -7? No solution. Now, if this had been a +7, from here you'd split it and solve it the rest of the way. But when you have absolute value and there's a variable inside the absolute value but none on the outside, so like this where I only have variables on the inside, I will always have either no solution or 2 solutions. So it's either none or 2. There's no other option. Yeah. Unless, now if there's a variable on the outside of the absolute value, then it changes things a bit. Now we're doing that next. Does everybody have this? Okay. So we have x is both inside and outside of the absolute value bars. We have to check both answers because they might both be true, or it might only be that one of them's true. You get false solutions with this sometimes. So what I have is I have x plus 10 is equal to 4x minus 8. Or sorry, the absolute value of x plus 10. So I have to split this. So I get x plus 10 is equal to 4x minus 8, and I get x plus 10 is equal to negative of 4x minus 8. So if I solve this, I can subtract x from both sides. So I get 10 is equal to 3x minus 8. Then I can add 8 to both sides. And I get 3x is equal to 18. Divide by 3. And I have x is equal to 6. Over here, I need to distribute this negative. So what I get is x plus 10 is equal to negative 4x plus 8. I add 4x to both sides. I get 5x plus 10 is equal to 8. Subtract 10. And I get 5x is equal to negative 2. And if I divide by 5, I get x is equal to negative 2/5. Now, these might both be true, or it might be that one of them is true, and it might be that neither of them is true. That's very rare, though. So to check them, what I have to do is I have to go back to the original problem and plug in the answers. So I get the absolute value of 16 is equal to 24 minus 8. So 16 is equal to 16, and this is true. So this one's good. And then I get negative 2/5 plus 10. Well, 10, if I put it into terms of fifths, it's 50/5 is equal to 4 times negative 2/5 minus 8. Sorry, that's really squished. So this is 48/5 is equal to negative 8/5 minus, if I do negative 8, that's going to give me a negative something, right? So I'm going to get 48/5 is equal to negative some number. I don't even, do you understand? I don't even have to add these together. A negative plus a negative is a negative, and a positive does not equal a negative. So this is not a solution. Well, actually, I didn't even have to go that far. I had the absolute value equals negative. I could have stopped there. Does that make sense? So if you get anything that's not true, so absolute value is going to be equaling negatives, or positive equals a negative, or maybe I got 48/5 equals 23/3 or something, it's not a solution. So my only solution on this one is x equals 6. Okay, so see, I cannot distribute in. Remember I said it's a wall, I can't distribute in. So I'm going to try to get rid of this x first, so I'm going to add x to both sides. So that's going to give me 2 times the absolute value of x plus 1 is equal to 4x minus 4. Then I'm going to divide both sides by 2. So I'm going to get the absolute value of x plus 1 is equal to 2x minus 2. And now I'm going to split it. So I get x plus 1 is equal to 2x minus 2, and x plus 1 is equal to negative of 2x minus 2. Subtract x from both sides, and I get 1 is equal to x minus 2. Add 2 to both sides, and I get x is 3. Over here, distribute your negative to get x plus 1 is equal to negative 2x plus 2. I'm going to add 2x to both sides. So 3x plus 1 is equal to 2. Subtract 1 from both sides. 3x equals 1, so x is 1/3. And now I have to check them. And you don't have to go all the way back up here. You can do this one right here.
Wait. Why is that 1/3? That's supposed to be 3x, not 2x.
Where?
In the where it's or x plus 1 equals negative 2x, it's 3x, not 2x.
Here?
Yeah.
How is it 3x?
Because it says 3x up there, not.
I subtracted x from it. Or I mean, I added x to it, which gave me 4, and then I divided by 2. Okay. So I'm going to plug in the 3 first. So I get the absolute value of 4 is equal to 6 minus 2. So 4 equals 4, that's true. If I plug in the 1/3, just minus 2. That's, well, we could do 1 1/3 is equal to 2/3 minus 2. Is this going to be positive or negative? It's going to be negative, right? It's going to be 1 1/3 is equal to negative 1 1/3. That's not true. So this is not true. So my solution is just x equals 3. I'm going to show you how to do this the algebraic way using an absolute value equation, and then I'm going to show you how to do it the easy way. Okay, so standard adult tennis racket has a 100 square inch head plus or minus 20 square inches. So we're going to write and solve an absolute value equation to determine the least or greatest possible sizes of the head of an adult tennis racket. So we have plus or minus 20 inches. So that's going to be, hold on, I have to think about it. So x minus 100 is equal to 20. So when you split that, you get x minus 100 is equal to 20, or x minus 100 is equal to negative 20. Add 100 to both sides. And you get x is equal to 120 or 80. Now, the easy way to do that, 100 square inches plus or minus 20 inches. Plus 20 minus 20. That gives you 120 or 80. All right, so solving inequalities. I'm going to give you the properties. It's true for less than, greater than, less than or equal to, greater than or equal to, and also not equal to. This little symbol here means not equal. So you can say things like 2 is not equal to 3. That's true. Okay. So the addition property of inequality says that if A is less than B, and if I add something to both sides and it's the same something, it's still less than. So for example, if 2 is less than 3, 2 plus 5 is less than 3 plus 5. Right? 7 less than 8, still true. Works the same way for greater than, less than, everything. Oops, plus C is greater than B plus C. So if I add the same thing to both sides, the inequality doesn't change. Same thing for subtraction. If A is less than B, A minus C is less than B minus C. So if I take the same thing away from both sides, so for example, 10 is less than 19.
Oh.
6 is less than 15. It's still true. Okay, shh. You add or subtract the same thing to both. It's basically, you solve an inequality exactly the same way as you solve an equation. The only thing that is different is the symbol. So I'm going to add 6 to both sides. So y is less than 3. Now we have to graph these. If you have less than or greater than, you graph with an open dot. And if you have less than or equal to or greater than or equal to, you graph with a colored in dot. So, yes. 9, yes, thank you. I extra credit. 9, thank you. So y is less than 9. I have an open circle on 9. Okay, and which side of numbers are less than 9? side over here, right? So then I shade this whole thing. So y can be any number from here over to negative infinity. So then I'm going to subtract 3 from both sides.
Where did you get 5W? Yeah,
What? 1W, thank you. See, this is because they're so loud.
I know.
So W is greater than 6. So I'm going to go to 6, and it's a greater than, so I'm going to make an open circle. And greater than is everything to this side. So that's what I shade. A is less than B, then AC is less than BC. And this is true for all, again, less than, greater than, etc. And this is like if 2 is less than 5, then 2 times 3 is less than 5 times 3. This is true, right? 6 is less than 15. Now where it changes up is if C is negative. If C is negative and you multiply both sides by a negative, you have to flip the inequality. And the reason this happens is because if I say 2 is less than 5, and then I multiply that 2 times a negative 1 and 5 times a negative 1, this is negative 2 and negative 5. Negative 2 is greater than negative 5. So whenever you multiply by negative, what you've actually done is you've essentially turned yourself around on the number line. So you have to flip the inequality.
Well, that's not too bad.
No, it's not too bad. It's the same thing with division. If A is less than B and I divide both sides by C and C is positive, they stay less than.
Disturbing class. Could you disturb me?
4 is less than 6. If I divide both sides by 2, I get 2 is less than 3. That's true. Right? But if C is negative, again, I'm dividing both sides by a negative. I have to flip the inequality. And we'll use the 4 and 6 again. If I divide 4 by negative 2 and 6 by negative 2, that makes negative 2 and negative 3. Negative 2 is actually greater than negative 3. So the rule is anytime you multiply or divide both sides by a negative number, you flip the inequality. Okay. Okay. Dividing by a negative. This is multiplication, so I have to divide by a negative. And I never memorized my 29.4s, so seven. So x is greater than or equal to 7. So what I had to do, because I divided by a negative, is I had to flip my inequality. And now I'm greater than or equal to, so I go to 7 and I'm going to put a solid dot. And then I'm shading everything. Huh? No, it's a flip. See, I flipped.
It looks like a 6.
It's a flip. Okay, let me change my flip. I'm gonna flip. Okay.
How do you make it so difficult?
It's a flip.
Nobody asked what the square was.
All right, if I multiply both sides by a negative number. So this is division, right? It's not a fraction, it's division. So I'm going to multiply both sides by -2. And I'm going to flip my inequality. And I'm going to get x. Why are there equal signs there? Change that. I don't know what I was thinking. So it was less than or greater than or equal to, so now it's going to become less than or equal to -20. All right, we don't have a 20 on here. So we're just going to draw a line out like this, and we're going to put, right, sorry, wrong side. We're going to say, okay, -20. Less than or equal to is this way. Here we're dividing by positive number. Even though this is negative, I divided by a +4, so my inequality does not flip. So I have -6, and it's greater than, so that's over here. And here I'm multiplying by a +5, so I'm not flipping, and I'm going to get x is less than or equal to 60. Again, I don't have a 60, so I'm going to extend that, and I'm just going to put 60. And it's a solid dot because it's less than or equal to, and everything to this side gets shaded. Okay. Multi-steps, we have to get this fraction gone first. So we're going to multiply both sides by 6. So we get -24c is less than or equal to 5c plus 58. So I'm going to subtract 5c from both sides. And I'm going to get -29c is less than or equal to 58. I'm going to divide both sides by a -29, and since I divided by a negative, I'm going to flip the inequality. So c is greater than or equal to -2. So colored in circle because it's greater than or equal to, and everything bigger than -2 is on this side. Once I distributed, now I have to move all my v's to one side, so I'm going to subtract 20v from both sides. Now remember, adding and subtracting doesn't change anything. I'm going to add 18 to both sides. So I get 4v is less than 24. I'm going to divide by 4, which is positive, so nothing is changing. Okay, I don't have a 24, so I'm going to extend this out, and then I'm going to just say 24. 6. Thank you. Thank you, thank you, thank you. Who said that so I can... Okay. All right, 6. See, this is what happens. All right, I have an open circle because it's less than, and less than is on this side.
So you always have to like color it in if it's more than?
Yes.
Okay.
No.
There's when it doesn't have a line underneath it, you leave it as.
Yeah. So if you have this or this, it's open circle. If you have this or this,
Oh, that's when it's closed.
Oh, okay.
it's a closed circle.
I got no results.
Man.
Do you want
No. Like we're doing
No.
Type in just 8 in algebra. Website earns $15 per month plus 5 cents every time a visitor clicks the ad. And we want to know what is the least number of clicks that Salim needs in order to earn $50 per month or more. Okay, whenever you're talking about least, or most. So at least or at most. So we were saying like he wants at least $50, right? So at least is going to be greater than or equal to. If you're talking about at most, it's less than or equal to. Okay, but we want at least $50. So it's $15 per month plus 5 cents per click. I'm going to use X for click, and we want that to be at least $50. So I'm going to subtract 15 from both sides, because he makes that automatically. So 0.05x is greater than or equal to 35. I'm going to divide both sides by 0.05. So it's 700 clicks. So he needs at least 700 clicks on that ad in order to earn that $50. Obviously, we don't go out to 700. So I'm just going to put a 700 there. Greater than or equal is a solid dot, and then we want it to be more than 700.